Hello and welcome to the first section of Chapter 5. We're going to be working with the midsegment theorem and coordinate proofs. Alright, so first I'm going to describe what a midsegment is. Every triangle has three sides, therefore it has three midpoints. And if I connect two of the midpoints, that creates a midsegment. Because there are three sides, as I mentioned, there are three midpoints, so there is actually three midsegments in every single triangle. And that is what this is. Then there is a theorem that goes with that, and it's that when you have the midsegment, say DE, DE is going to be half the length of the side, the other side that doesn't connect the midpoints on. So it's going to be half of AC, or AC is double DE. The other property is that these two lines, the midsegment and that line, they're going to be parallel. We're going to prove this using a coordinate proof, which we will be doing later on. And I'm going to do most of the coordinate proof stuff in class, and then, but I'm going to show you kind of how to set them up during this video. So here we have a bunch of midsegments. It says a bunch of midsegments in this triangle. So if this is 57, we're going to double that to get 108 for SR, and this is 90, so we're going to cut that in half to get 45 for UV. This is a problem that is in the book. And I like it. These are all midsegments, by the way, in the book. I forgot to draw these marks here. And they say that AB is 3x plus 8. These are really good problems, by the way. These are kind of the level at which you guys will be working at. And then GJ is 2x plus 24. So if I double 3x plus 8, it'll give me GJ. So double 3x plus 8. That's going to equal 2x plus 24. So that will be this here. If I use the distributive property and then some algebra, 4x equals, subtract 16 to get 8, so x equals 2. And then they say find AB, so 3 times 2 plus 8, that'll be 6 plus 8 is 14. All right, show that CB is parallel to DE. So AE is congruent to BE. That makes this a midpoint. And AD is congruent to CD, so that makes that a midpoint. So if I connect the two midpoints using the midsegment theorem, that means that DE must be parallel to CB. This is from Zelda, by the way. If you've ever seen Zelda, this is the Triforce. Okay, coordinate proofs. So I'm going to show you guys kind of how we set up coordinate proofs. And then we're actually going to work on them in class because they are a little tricky. So we're going to be using variables to represent coordinates. And the only number you can use, 0, is the only number you will use. Everything else will be in terms of a variable. So we're going to put a rectangle here conveniently. 0, 0, the origin is almost always going to be used. And then we got to assign coordinate values. So I'm going to call this m comma 0. I'm going to go over m units up 0. This one I'll call 0 comma n, left or right 0 up n. And then there's my rectangle, which makes this last coordinate m over m up n. All right, a scalene triangle, there's like an infinite number of answers for this one here. So again, I'm going to use 0, 0. I'm going to use m comma 0. And we'll call this point a comma b. You go over a up b. So that's placing a figure in a coordinate plane. I got one more here for you. This one has a square at 0, 0, m 0. Now, why did I choose this point to be m? Because I can. You don't have any values associated with any of these grid lines. It doesn't say they're 1 by 1 by 1 or 1 by 1. So find the fourth vertex. To get to this point right here, I go over m up m units. So it's going to be m comma m. All right, place an isosceles right triangle in a coordinate plane, then find the length of the hypotenuse and the coordinates of its midpoint. This is a very good question. This will help us for the coordinate proofs. Isosceles right triangle. Okay. I'm going to go like this and like this. So now the isosceles triangle, we have isosceles right triangle. So this is going to be m comma 0, and this is going to be 0 comma m. And then it says find the length of the hypotenuse. So it wants this length right there. So I'm going to use the distance formula. X2 minus x1 squared, so 0 minus m squared plus y2 minus y1 squared. Review of the distance formula if you don't remember that. This is going to give me m squared if I have negative m times negative m. This is m times m, or m squared, so together that is 2m squared. Then we learned how to reduce or simplify radicals. So I'm going to split this up. And so the distance is equal to m root 2 as my simplified answer. This is going to come up later on in the year, by the way, just as a preview. All right, and then we need the midpoint. So the midpoint formula is x1 plus x2 divided by 2. So 0 plus m divided by 2, comma, y1 plus y2 divided by 2. You should have those formulas somewhere in your notebook. If you don't, rewrite those down. All right, so here's our midpoint right there. That is the half of m gives me the midpoint of that. This is going to be very helpful for coordinate proofs. So we're going to do this in class. And these problems here go with these problems here. They're just some extra problems for you to take a look at. They're good problems. All right, that's all I got for 5.1, and I'll see you in class for Learn How to Do Coordinate Proofs.